of triangles and quadrilaterals today. All right? Just those things. Some of you, I know you had some homework on it last night for a little refresher, but I'm going to try to show you some stuff to make these equations stick. Because the reason these equations work are because of math. Like, you don't have to memorize them. There's actual reasons for them working. So the first equation we're going to look at is for a parallelogram. A parallelogram would include a rectangle, a square, a rhombus, all these things that have opposite sides that are parallel. So stuff that looks like this, stuff like looks like this, something that looks like this, that has all equal sides, that's a rhombus. Okay, this is a parallelogram. What am I missing? Rhombus, a rectangle, opposite sides are parallel and equal, and it has right angles. So all these things have the same equation. Titus.
I think I might have seen it.
Okay, so here's all the parallelograms. All right, and here's the equation. Area equals base times height. Now, you probably know why that's the equation when you have a nice old rectangle, right? You can cut it up into these boxes, these units, and you can say 4 by 4, there's got to be 16 in there, right? Okay, a little harder to explain why it works for this, right? Because can you make little boxes in there?
No.
No, but here's the dealio. You ready for this?
What?
Let's say you had, like, your favorite device to cut things, okay? A chainsaw, scissors, a shank, okay? And you cut this guy right here. Boom. You just lobe off a triangle. And then you take that triangle and you stick it right there.
That's what I always thought.
Look what you've got. You've got yourself a rectangle, which is just area equals base times height. So when you have the parallelogram or the rhombus, the information you need to know for the height is this perpendicular height. All right? If you know what this is not the height. The height needs to be perpendicular to the base. And that's why this works, even for the slanty guys. Because you can lob off an end, put it on the other end, you just made the whole thing into a rectangle. Using math, which is cool. You guys see that visual?
Yeah.
Really? You're just making your math make it into a rectangle. That's why it works.
Wait.
Base times height. Next, I want to talk with you about my favorite quadrilateral. Because it reminds me of Star Wars.
And sometimes they look like shoes.
That one guy with like the red head, he's like, "This is a trap." So I don't know. That's what I always think about. General something. Schmuckers? Admiral Akbar. Almost. It kind of sounds like Schmuckers.
But he's kind of red.
Okay. Isn't it like reddish orange face or is it brown?
I don't think it's red.
Maybe I'm confusing it with the guy from Futurama or something. Okay. So, in trapezoid, you guys know that a trapezoid has exactly one pair of parallel sides. That's what makes something a trapezoid. So, a lot of them look like this, or like these would be like the most common, but assuming that these are parallel, Okay? Again, we're going to be looking for that perpendicular height on these as well, guys. Okay? So I'm going to give you the equation, and then I'm going to explain to you why the equation works. There's a couple different ways to explain it. I like the way I explain it. That's why I explain it that way. But I memorize the equation by concept, not by memorizing the equation. And so I'll give you the equation, and then I'll explain to you the concept. So the equation I like to use is this one. 1/2 times the area, or 1/2 times base 1 plus base 2. So on these parallelograms, there's two bases. That's a subscript 2. It's not an exponent. Times the height. Another way you might see this is base 1 plus base 2 times the height divided by 2. They're the same thing. This is my favorite, and I'm going to show you why in just a second, okay? James, can I get to your question after I explain a couple things? Okay. So here's this trapezoid again. All right. My height is going to be here. I got base and a base. So here's what I want you to focus on this part of the equation for a second. Adding two things together and dividing by 2. What are you finding? In math, when you add things together, divide by how many there are. What is it? The average, right? So the average takes things that are different and makes them the same, correct? Like if you're bowling, your average means you take the games that you bowled more, the games you did less, you even it all out and say, I scored about this. Well, that's all that's happening to our trapezoid right there. So that 1/2 of base 1 plus base 2, what you're doing is you're making that a little longer and that a little shorter to make them the same. And if those are the same, guess what you've got? A rectangle. Are you guys seeing that?
Wait, why not a square?
Well, it could be a square. I just don't know. So if I say rectangle, a square is a rectangle, and I'm right either way.
What?
I don't know if this is the same. I don't know if the height's the same. I just know the bases are the same. So imagine it on this one up here. You make your shorter base a little longer. You make your longer base a little shorter, and you got yourself a rectangle. If the bases are the same, then you've got yourself a rectangle. So that's how I memorize that equation. I average my bases, it makes it into a rectangle, and then it's just base times height. The average base times the height. That's how I memorize it. Are you guys seeing that visual?
Yeah.
I'm going to draw it one more time because it's awesome. It's how I memorize the equation. I don't sit there and think letters, numbers. Okay? So if I average the bases, that one comes longer, that one becomes that same amount shorter, I've got myself a rectangle. And that rectangle I can just do base times height. That's all this is right here. The average of the bases makes it into a rectangle. It's cool. Yeah. All right, guys. Let's look at triangles next. Do you know why they're called triangles? No, the reason is there's a guy named Sir Triangle. He lived in like Britain. I think it was like 500 BC. So it wasn't quite Britain. There's some native people there. And Sir Triangle was like, he was really into this thing. It was like this, and then like this. And so he said, this thing, I'm going to call this a triangle. So it's just coincidence that tri means 3 and angle means angle and 3 angles in a triangle, I think. But this is, you can thank Sir Triangle for this. Okay.
Wait, so Sir Triangle's the Illuminati?
I don't know. I just know that he made the shape and then named it Triangle after himself. And I heard, just a rumor, I heard like Will Smith is his great-great-great-great-great-grandson. And that Jay-Z is his great-great-great-great-grand-uncle. Okay? So, triangle area. Let's look at this. Triangles they have 3 sides. I think you know that. Okay? Now here's the deal. Here's the deal. If you have a rectangle, area equals base times height, and then you cut that with your cutter of choice, what do you get?
2 triangles.
2 triangles. So one of those triangles would be half of the base times height of that rectangle. All based on the same exact equation, base times height. A triangle is, you give me any triangle, boom. It's half of this parallelogram. You feel me?
I see. Wait.
Titus.
So, right triangles,
Oh.
you have to split it in half.
Good question. So,
That's what.
you need to know your information. So, the base and height, again, have to be perpendicular to each other. So let's say this is my base of 6, let's say, for example. Then this would have to be my height. Let's say it's 8. Base and height doesn't have to be bottom and top. Because in geometry, I can take this triangle and flip it any way I want. It's still the same triangle. Does area change if I hold it upside down? No. So your base and height, all you need to know for base and height is it needs to be perpendicular. You could have any side of your triangle be the base. But the height has to be perpendicular. Now, you bring up a good point, Titus. If you have a right triangle, you got a base and height already because you're perpendicular. But if it's not a right triangle, you need to look for that dashed line to say this is height. Right now, I'm going to always give you the height. But in the future, we're going to learn this thing called the Pythagorean theorem, and you'll be able to find the height.
Well, yeah, because I've always, like, if it's not, like, a right triangle.
You're just like, nope.
Yeah, I just slice it in half.
But yeah, but you can't always slice it in half. What if you have a scalene? Right? You'd have to get that perpendicular spot. Or they could show it to you like this, too. Let's see. They could show you, like, see that those dashes? The dashes means it's not part of the shape, but it's giving you a reference to get a right angle. Okay. Cool. You might also see, this is my favorite triangle equation right here. Maybe I better put it in a different. 1/2 BH, because I like that idea. I'm cutting it in half. I also see people do this, and it's the same thing. I don't care which one you use. But when you give me the area of things, oh, why did I just box the rectangle? This is your area. But when you're doing these problems, I'm going to model one for you in a second here. Like, let's say, and we'll do a pretty simple one. 2x4 rectangle. You're going to say area equals base times height. Area equals 4 times 2. Area equals 8 square units, whatever the units are. That's the work you'll need to show me for every geometry problem with area or volume. Yeah, because you're showing me what this is math is what? Communication. You're showing me what you're using there. Why are the units squared, do you know? Yeah, James.
Because area isn't one, it's not like the length, it's the length times width.
Yeah, 2 dimensions.
Squared, you're figuring out.
2 dimensions, right?
Yeah.
Now, another way to do it is if you wrote down 4u times 2u, that's 8. What's u times u is u squared, right? That's another reason why.
X,
Miles times miles are miles squared.
if X plus
Okay, cool.